Have you ever opened your inbox, seen exactly zero spam, and just wondered, how do machines actually learn to do that? It's kind of tempting to look at artificial intelligence and just see it as magic, right? A mysterious black box that somehow just knows the answer. But the truth is actually much more fascinating, and frankly, a whole lot more logical. Machine learning is a highly rigorous, structured process.
Well, let's dive right into this explainer. Today, we're literally tearing down that illusion of the black box. We're going to look at the true life cycle of machine learning systems. By understanding this as a systematic life cycle, rather than just some opaque algorithm, you'll see exactly how real-world AI systems are built from the ground up to continuously improve their predictions and decisions. Here's our roadmap for the explainer. We'll be moving through 5 key phases: demystifying machine learning, defining the exact problem, gathering and cleaning data, training and evaluating models, and finally, real-world deployment and monitoring.
All right, kicking things off with Section 1, demystifying machine learning. It's not magic, it's a cycle. The absolute biggest mental shift you need to make right now is realizing that building AI, it's a continuous loop. We're talking about 7 overarching stages: problem definition, data collection, data preparation, model training, model evaluation, deployment, and monitoring and improvement. And I really want to stress that word, cycle. These stages aren't just a straight line. If a model completely fails at one point, developers don't just throw their hands up in defeat. No way! They systematically loop right back to an earlier stage and fix it. It is basically a never-ending engine of improvement. Moving on to Section 2, defining the exact problem. This is absolutely the critical first step. So long before anyone writes a single line of code or boots up some fancy algorithm, developers have to know exactly what they're trying to solve. You have to clearly define your goal and the specific output you want. Like, maybe a company wants to predict house prices based on location and square footage. Or, and we'll use this as our main example today, maybe the goal is to detect spam emails. Pinpointing that precise problem, separating the absolute junk from the stuff you actually want to read, that sets the foundation for the entire system. Because if you don't define the target right from the get-go, the machine is going to have absolutely no clue what it's even looking for.
Which brings us to Section 3, gathering and cleaning data, the literal fuel for the system. Now, machine learning systems learn entirely from data. This raw material gets pulled from all over the place: websites, sensors, surveys, massive databases. It powers everything. And I really want to pause on this idea because it is the golden rule of machine learning. The quality and quantity of data strongly affect the model's performance. Think about our spam filter. It is truly, honestly, only as good as the giant pile of emails it studies. If you give it a tiny data set or just stuff that doesn't look anything like a real-world inbox, your model is absolutely going to flop.
And that perfectly highlights why data preparation is such a massive deal. On one hand, you've got raw, messy data. We're talking incomplete info, glaring errors, missing values, just pure, unadulterated chaos. But on the flip side, you have cleaned, beautifully organized data. Errors are gone, formatting is consistent, and the important features are front and center. A machine simply cannot learn from chaos. Stripping the errors out of our spam database is exactly what lets the algorithm actually spot the patterns we want it to find.
So, the microprocess here is actually pretty straightforward. Step 1, collect the relevant data. Step 2, clean and format the whole thing, making sure to handle any of those missing pieces. And Step 3, this is absolutely crucial, split that data into training and testing sets. It's kind of like being a teacher. You hand the AI a massive stack of flashcards to study from, right? That's your training set. But you intentionally hide a smaller stack of flashcards in your desk for the final exam later. That hidden stack, that's the testing set.
Okay, let's head into Section 4, training and evaluating models. We are building the brain.
This right here is where the actual learning happens. The algorithm takes that squeaky clean training data we just prepped and studies it to uncover all those hidden patterns. During this phase, developers have to pick the right algorithm for the job. They might go with decision trees, neural networks, or maybe regression models. But no matter what heavy math is running under the hood, the core concept is exactly the same. The machine is actively studying our clean dataset, mathematically crunching the numbers to figure out what exactly makes a spam email, well, spam.
Once the studying is done, it's time for the evaluation. Step 1, train the model. Step 2, test it using that brand new, hidden data. Yep, the final exam. Step 3, measure how accurate and reliable it really is. Did it successfully catch the spam, or did it accidentally throw your boss's incredibly important emails straight into the trash? And Step 4 is where the magic really happens. If the results are bad, we loop back, We iterate, we improve the data, or we swap out the algorithm entirely and we just try again. Finally, we arrive at Section 5, Real-World Deployment and Monitoring, the climax of the whole process.
Getting that highly trained, super accurate spam filter directly into your live inbox is the ultimate goal. Once a model aces its final exam, it graduates. And you see this in so many tools you use every single day. A deployed model becomes the recommendation system telling you exactly what movie to binge next. It becomes the friendly chatbot handling your customer service returns. Or it becomes the invisible fraud detection system quietly locking down your credit card. The real-world stakes of a well-executed machine learning cycle are just incredibly high.
But listen, the work doesn't just stop the second the system goes live. The absolute crucial point to remember here is that machine learning models must be monitored regularly because data and human behavior change over time. Think about it for a second. Spammers don't just give up when a new filter drops. They completely change their tactics. They use bizarre new keywords, they disguise their malicious links differently. Because the real world is constantly shifting, developers have to continuously update and retrain their models just to keep them effective.
So the cycle truly never ends. It's just a constant, relentless pursuit of adaptation. Which leaves us with one final, fascinating question to ponder. Knowing that this is a never-ending loop of learning, training, and evaluating, as human behavior inevitably changes, will your model be able to keep up?